Hello and welcome back to OTS. In this video we'll be going over blocks and hanging masses, as well as how to tackle problems like these and what it means intuitively. Okay, so let's start. These problems look very similar to this, with two blocks attached, maybe a pulley or two, and gravity sets this thing in motion. As this moves in motion, this follows it in this direction. Okay, that's basically what these problems are. And sometimes you can add friction, or sometimes you can not have friction. So you can see over here how it says frictionless here, right? So this will be approached very similar to the Atwood machine. I look at one of them, so I'll look at the 10 kg here. I'll draw a free body diagram. So we have mg here, normal. But then what do we have? We have tension, right? The tension in the rope is pulling it to the right. Normal and mg cancel out, so it's only tension. Tension is equal to net force, right? Because that's the only force there. So tension is equal to m times a. And in this case, that would be 10 kg times a. Okay? And then for the 5 kg block, you would just look and say, well, what's the net force acting on this block? We have tension pulling it upwards, right? That's what's holding it up and didn't leave it stranded. What's pulling it downward? mg. So tension minus mg is what's going to bring your block down, right? And that's going to be equal to net force is equal to ma. And this is the net force, right? Because we're adding both of them, or in this case, subtracting. So this would be just ma. But remember, since a is downward, right? It's going to be accelerating downward. So I'm going to put a negative a here. It's just going to become negative ma. So tension minus mg is equal to negative ma, because acceleration is going to be downward. I can substitute this. These m's, I know what they are, right? So in this case, tension minus mg is 5 times 9.81. So 9.8 is equal to negative ma, negative 5a, right? So tension is just so tension minus 49 is equal to negative 5 kg a. And then I know what tension is here, right? So I can just substitute that into this. 10 kga minus 49 is equal to negative 5 kga. I add 5 kga to both sides. 15 kga is equal to, I get rid of this 49 on the other side. 49. A is equal to 49 over 15, which is approximately 3.27, repeating, or just 3.27 meter per second squared. And then I can plug this acceleration into this tension equation to find out what the tension is, right? If I wanted to. I don't need to right now, but if I wanted to. So that's how you solve these problems. Very similar to the Atwood machine. Draw free body diagrams for both, and then calculate the net force and have at it. So this is similar to what I did, okay? And this you can call the no friction formula. A is equal to m2g over m1 plus m2, where m2 is the object which is falling. You don't need to memorize it, it comes naturally, okay? Instead of using all these substituted in numbers, if I was to use variables, then I would get this same answer. This is what I was talking about, and then you can plug in for tension, right, to find the value. But now let's talk about what happens when you bring in friction. So you have that same 10 kg plus 5 kg system, okay? So I'm going to just draw the same thing again. 5 kg, 10 kg. Friction acts on the block using its own normal force, okay? And then since this block is not the one that has friction, right? It's in the air. This block is the one that has friction, so this block is going to be pushed backward like this. Alright, pretty straightforward. Hanging, so I'll write the equations again, but this time, when I look at the 10 kg block, I have to remember that there's two forces, okay? So when I go here, first I draw normal, which keeps it on the table, and mg, but these two cancel out, because it's not moving to the table and it's not being pushed up by the table, right? Then I have tension because the rope is pulling me this way. But what else do I have? I have a tad bit of friction in this way. Okay? And then for the 5 kg block, it'll stay the same because the block isn't affected by friction. So for that block, free body diagram is still mg and tension this way. Okay? If I was to write the equations for the first block, I would write tension minus force of friction is equal to MA, or the net force, right? So what is tension? I don't know that. But force of friction, I do know that, right? Tension minus, remember what the equation for the force of friction was? For kinetic friction at least. Mu times the normal force. So mu is 0.4. Do you know what the normal force is? That's just going to be exactly the force of gravity, right? Because it's counteracting that force to keep it on the table. It's not making it through the table, or it's not pushing it upward. So normal force will cancel out with gravity, which means normal force is equal to the force of gravity. N is equal to mg, which is 10 kg times 9.8, or 9.98 newtons, is equal to MA. So then 0.4 times 98, tension minus 39.2 newtons is equal to MA. In this case, M is 10 kg times acceleration. Okay? Let me just tidy up this 39 here. Okay, so now let's look at the other equation, which is going to be for this block here. So no crazy stuff, similar, right? Tension minus mg, which in this case would be 5 times 9.8, is equal to MA, and A is going in the negative direction, so it's going to be negative MA. Okay? Tension minus 5 times 9.8 is equal to negative MA, yeah. And negative M, I can just replace that with negative 5 kg. Negative 5 kgs times acceleration. Alright? And if I wanted to solve this, I could just substitute either tension into the other one. So I could just do tension is equal to this plus this, and then I could substitute that into here. Or I could do the other way. For now, I'll do the other way here. Tension is equal to 10 kGa plus 39.2 Newton. Right? So I'm going to substitute that into here. So that's going to become 10 kGa plus 39.2 minus 5 times 9.8. Right? So 5 times 9.8 is 49 is equal to negative 5 kGa. Okay. Then I'm going to remove this so I have some more space here. So then I'm going to add these two because this is 5 kGa and this is 10 kGa. 15 kGa is equal to 49 minus 39.2. I just brought this other stuff to the other side. So I'm going to get this is equal to 9.8 and A is equal to 9.8 divided by 15, which is going to be 0.65 meter per second squared. Okay, So yeah, that's it. That's how you work through this. All right. So obviously you can memorize formulas here, but I would like you to know how to do these problems intuitively, not just formulas. And then you can plug this acceleration into any of the tension equations to find the tension. But so far that's right. So now let's work through some problems regarding tension and, the friction as well as blocks and hanging masses. So we have a 6 kg block on a frictionless table that connects over a pulley to a 4 kg hanging mass. So somewhat like this. Okay. Find the acceleration and the tension. For the 6 kg block, the only force acting on it would be tension because there's no friction here. Mg and normal cancel out. Okay, so tension is equal to the net force, which is M, 6 kgs, times A, which will be similar for both of these blocks, but we don't know that yet. For 4 kg block, it would be Mg. There's no normal here, there's only tension. Tension minus Mg is equal to negative Ma, right? Because A here is its downward direction. And since I considered Mg as downward, I need to consider Ma as downward as well. So it's going to be Mg here would be 4 times 9.8 is equal to negative, so same mass here is 4 kgs, times acceleration. So it would be 4 times 9.8. Tension minus 39.2 is equal to negative 4 kg A. So this would be newtons here. And then 10T is equal to 6 kg A. I can just substitute that in here. Okay. So I'm going to get 6 kg A minus 39.2 newtons is equal to negative 4 kg times A. If I add this to both sides, right, I'm going to get 10 kg A minus 39.2 newtons is equal to 0. And then if I add this 39.2 to the other side, 10 kg A is equal to 39.2. And A is equal to 39.2 over 10. And that's 3.92 meter per second square. Now, in order to find the tension, I just need to plug this acceleration into one of my equations. And I'm going to plug it in over here because that's a bit more easier, right? Tension is equal to 6 kgs times 3.92 meter per second squared. So around 23.52 newtons. Alright, so that's pretty simple there. And now let's work through this second problem here. The same system, but now we have mu k is equal to 0.25 on the table. So we have something pulling it backward. So while tension is pulling the 6 kg block forward in the rightward direction, we have mu k. Remember the force of friction was mu times normal force, right? Is equal to net force or mass times acceleration. So tension minus mu k is 0.25. And then the normal force in this case is going to balance out with mg, right? Because it's not sinking through the table or it's not being pushed up. So mg here would be 6 kg times 9.8. And that's equal to 6 kg times acceleration. So if I multiply all of this out, I should get T minus 14.7 newtons is equal to 6 kg times A. And then for the other equation, which is going to be regarding the 4 kg block, Same thing, right? Tension is pulling it up, mg is pulling it down. So I'll highlight this equation as one of my equations. Tension minus mg is equal to ma. This will be negative because the block's going downward. If mg is negative, then ma has to be negative, right? Tension minus m is 4 times 9.8 is equal to 4 times acceleration. So 4 times 9.8, 39.2. So T minus 39.2 is equal to 4A newtons here. And then if I erase all this fluff here, then I can substitute in T is equal to 4A, or as I remember, negative 4A, which I forgot to include, plus 39.2 newtons into this equation, which is going to give me negative 4A plus 39.2 newtons minus 14.7 newtons is equal to 6 kg times A. And then if I add 4A to 6 kGA, I should get 10 kGA is equal to 39.2 minus 14.7, which is 24.5 newtons. And A should be 24.5 divided by 10, or 2.45 meter per second squared. And then if I was to choose one equation to plug this into, I would just choose this equation here. So it would just be tension is equal to negative 4 times 2.45 plus 39.2. So that should be 29.4 newtons of force.